All right, this video is going to be about one sample proportion test. So the big thing here is making sure that you don't think this is two sample proportions, because usually two proportions are given. But we want to make sure that we understand how many ends are given, how many groups are given. So suppose that a consumer group suspects the proportions of households that have 3 cell phones is 30%. A cell phone company has reason to believe that it is not 30%. Before they start a big advertising campaign, they want to conduct a hypothesis test. Their marketing people surveyed 150 households with the result that 43 have 3 cell phones. Okay, so notice that our sample is just 150. And our successes is 43. And so this combination here, that gives us a p hat, 43 out of 150. We're now comparing that to, they think, the true proportion of all households who have 3 cell phones, right? They think that that proportion is 30%, but it's still only one proportion. I'm comparing this proportion to what I think is going on. It's kind of like the swimming goggles situation where like I have a standard I think that's happening. I go collect some data and I compare that to a population proportion that I think is actually happening here. So I'm going to center my distribution at 30. And I just want to know if it's not 30. Okay, it doesn't say less than or greater than, just not. So that's the center of my distribution, 0.3, 0. And then I'm going to run a two-tailed test. Now, since this is a proportion, I can use the z distribution. And I'm going to use an alpha level of 0.05. When it's not given, that's just what we do. But we have to split up that significance level into each one of our pieces here, which means our critical value is much like the confidence interval critical value of plus or minus 1.96. All right, our z is going to be that p hat that we'll calculate minus 0.3 all over, and then the standard deviation calculation uses, what was our n, 150, right? Uses the center of this distribution that we think is true, the one that we are assuming is true. All right, again, I'm going to use StatCrunch in order to enter this data. So stat proportions, 1 sample with summary. I have 43 successes out of 150 observations. I'm assuming 30%. I want to run a not equals to. Go ahead and show me the critical value, and let's compute this. So that sample proportion is 0.287. So this calculation, this right here, is equal to 0.287, as that's what that means. And what is the critical value that we get? It was 1.96, we got that. Okay, z statistic, that's only negative 0.36. So the z that we get is negative 0.36. And notice that that is not in our rejection region. Not even 1 standard deviation away from the mean, right? Like not in the rejection region. And the probability in the output, it was like, what was it, like 70%? Yeah, like 0.7216, which is not less than our significance level, right? So in this case, we're going to fail to reject HO. There is no significant evidence that the true proportion of households with 3 cell phones is not 30%. So we think it's probably true that it is about 30% or somewhere in there.